We're going to jump to theoretical probability. We just finished up with misleading graphs, and I want you to do 10-6 before 10-5. 10-6 is about theoretical probability, which is, in theory, what you would expect to happen. Whereas 10-5 is about experimental probability, which is what is the probability once you've actually run the experiment. I think it makes more sense to start with the theoretical part, and then we'll do the experimental part. So I did on purpose want you to do lesson 10-6 before 10-5. Copy down your target, and just as a warm-up, I want you to define probability in your own words, and also give an example of how it's useful in the real world. And I gave you some pictures to kind of jog some thoughts. Pause the video, complete that, then press play to go over it. So you have the target written. Hopefully you have a couple ideas written about probability. Notice I'm betting that your definition of probability probably involves the word chance or likelihood or likeliness, how likely something is to occur or the chance of something occurring. Anything along those lines would be great. When you think about some examples, maybe you didn't limit yourself just to the pictures that I have here. Probability is definitely involved in weather predictions and stocks, in sports statistics. Maybe you thought of something outside of these as well, and if you did, that's great too. Probability is really everywhere in the world, and that's why I think it's such a fun lesson, because you really can see how this does correlate directly to your world. So theoretical probability is the number of ways an event can occur divided by the total number of equally likely outcomes. So copy that down. A fair experiment is one in which all outcomes are equally likely. So we could say, in theory, when you roll a die, each number is equally likely to occur. Then we could find the probability of rolling one of those numbers. So let's think about this with the dice. An experiment consists of rolling a number cube. We want to find the theoretical probability of rolling each outcome. So here's my number cube, and we can roll as many die as we want. The first one we're going to look at is what's the probability of rolling a 5. So I got a 5 on my third roll, but that's not the theoretical probability. In theory, what is the chances of getting a 5? Well, when you do the probability, you're going to write the probability notation. So we're going to say the probability of rolling a 5 is, this is just like function notation. Remember f of x? That's just how we read it. It's not f times x. So this is the probability of 5 is, well, the probability of 5 is going to be how many 5s are there on a die out of how many sides are there on a die. So on a die there are 6 sides, and one of them have a 5. The probability then is 1/6. If you wanted to use your calculator to get the percent, we could divide 1 by 6. And that's going to be the decimal, so then move the decimal point over 2 places to get the percent. This would be 16.6 repeating percent. I have my students just write the fraction, the reduced fraction of course, but you can always write the percent as well. All right, well, what about the probability of rolling an odd number on a die? So the probability of odd is, get used to that probability notation. I want you to write it on your notes and on your homework. Well, how many numbers on this die are odd? 5 is going to be an odd number, 3 is going to be an odd number, and the only other odd number we have is a 1. So we have 3 odds out of 6 sides in the die, and then reduce this. This is 1/2. Again, if you want to write your percent, it would be 50%. And then the last one, what is the probability of rolling a number less than 3? So a probability of number less than 3. You can abbreviate your probability notation, but it is important to write it. So again, please write that probability notation. It's just like function notation. Well, how many numbers on a die are less than 3? You have to think, does that include 3? Well, 3 is not less than 3, so there's only 1 and 2 that will satisfy this event. So there's 2 numbers on the die out of 6, which reduces to 1/3. And again, if I ask for the percent, it'd be 33.3 repeating percent. I wouldn't round them unless they tell you to. Well, the complement of an event is going to be all the outcomes that are in the sample space that are not included in the actual event. So basically, everything else that could happen. If we put all the students' names in a hat at our school, and I said, what's the probability of picking a 7th grader's name? The complement to that event would be not a 7th grader or an 8th grader, because that covers all the other students whose names would be in the hat, and there's no overlap there. Because there's no overlap, and because it includes all the values in the sample space, the probability of an event plus the probability of the complement of the event will always add up to 1, because these are all possible outcomes. You could do this, any event has a complement, okay? So if we're flipping a coin, the probability of the event might be, what's the probability of heads? Well, the complement would be the probability of not heads, which in this case would be tails then. But those always add up to 1. So we can use this complement idea whenever the problems get a little more complex. This one down here, number 2, is not very complex. However, we're going to work it out through the idea of this complement. A box contains only red, black, and white blocks. The probability of choosing a red block is 1/4. The probability of choosing a black block is 1/2. And the probability of choosing, and I want to find what the probability is of choosing a white block. Well, since it contains only red, black, and white, the probability of red plus the probability of black plus the probability of white must add up to 1. Red and black are not complements of each other, but red and not red are complements of each other. I could do the same thing with white or white and black. White is not the complement of choosing a black block, but white would be the complement of choosing a block that is not white, if that makes sense. So I know these probabilities will add up to 1. The probability of choosing a red block is 1/4. The probability of choosing a black block is 1/2. And I want to find the probability of white, so I'm going to leave that as an unknown. This is a variable, so probability of white. So you can see when solving this, the complement will help you, and we can, because we know that all the probabilities add up to 1 in total. So we can see here that the probability of white is 1/4. Again, this isn't an overly complicated event that you wouldn't be able to solve without knowing complements. However, we will get to some of those with 10-7, and as the probability gets more complex, the complement can be very helpful. Let's talk a little bit about odds. You've seen odds before. So with odds, they are very similar to probability, but they are different. I want to make sure you notice the difference here. Odds in favor will be found by writing the number of ways the event can occur. That's just like the numerator of your probability, but it's going to be a ratio written sideways to the number of ways an event cannot occur. So it's almost like to its complement. The odds against then are the number of ways an event cannot occur to the number of ways the event can occur. Take that E off of there. Sorry, that's just a typo. So if the odds in favor of an event are A to B, remember this is just a ratio, then the odds against would just be turning that around. It would be B to A. One connection you can make with odds and probability is if this is the number of ways the event can occur and this is the number of ways the event can't occur, then together those numbers will give you the total in the sample space. So write that down. That's important to know, and that'll help us whenever we're going back and forth between odds and probability. So the probability of rolling a number 2 on a number cube is 1 out of 6. So the probability of rolling a 2 is 1/6. Think about what you know about probability. The numerator is the number of ways it can be a 2, and the denominator is what in probability? It's the total. So if I want to find the odds of rolling a 2, that's the odds for a 2, what would that be? Well, how many ways can you roll a 2? How many ways can it occur? that would be the numerator, which is 1. 2, how many ways can it not occur? How many ways can you not roll a 2? Well, every other way on the die, or 6 minus the 1, so it would be 1 to 5. Again, probability is a ratio, but we normally write probability in a fraction form. Odds is a ratio, we normally write it with the colon form of the ratio. Let's try some more with this. The odds in favor of winning a contest are 1 to 9. I like to label this. It personally helps me. So this is odds in favor, which means of winning. So the first number is the way you can win, and the second number is the way you cannot win. I think just doing a quick label will really help you. So what is the probability of winning a contest? Well, the probability of winning, get that notation down. How many ways can you win? 2, the total number in the sample space. So 1 plus the 9 is going to give you the denominator. Notice when you're going from odds to probability, you need to add the ratio from the odds to get your total. What is the probability of not winning then? Well, the probability of not winning would just be the complement of what you have in A. So it would be the complement of 1/10 is 9/10. Or how many ways can you not win? 9 out of 10. So you can go from A or you can go from the odds. And the last odds problem, the odds against a spinner landing on red are 2 to 3. Let's label this. Odds against is what I gave you. It's against red. So 2, since it's odds against, 2 are not red, which means 3 are red. Again, labeling helps. So what is the probability of it landing on red? Get that notation down. Please do not skip this step. I require this as work. You may have to check with your teacher for grading purposes, but I expect you to write that. So the probability of red then would be, there's 3 reds. It's not 3 over 2. Remember, it's 3 to the total. So the total outcomes, the total numbers of outcomes in the sample space would be 5. Okay, on the bottom of your notes, you have a little lesson quiz here. 1 through 4 are going to be in your quick check on Blended Schools, so you can do them right here before you log in. And number 5 is the answer is going to be given to you at the end of this video. So go ahead and do 1 through 4. Then you're going to be given the answer to 5, and then you'll enter your answers in on 1 through 4 on the quick check to make sure you have them correct. Try all 5 now, then press play. So with number 5, I just want to go over this one because for some reason there's a lot of mistakes on this one. The odds against a spinner landing on blue. So let's label this. Since it's against blue, then the first one is not blue, which makes the 5 part that are blue. So the odds against the spinner landing on blue is 7 to 5. 5 sections are red. There's 5 sections that are red. There's 7 that are not blue, which means they could also be the red ones. And there's 5 that are blue. What is the probability of the spinner landing on red? Well, how many ways can you land on red? 5. And how many different outcomes could you have? Well, remember, you're just totaling these. So it would be 12. 5/12 then is your probability of red. Now, I could also ask you on that one, how many spaces are not red or blue? Or what is the probability of not red or blue, either one? So take a look at that. Can you figure that one out? If 5 are red, and there's 12 total, and you know how many blue there are, well, 5 are red, 5 are blue, which leaves only 2 out of 12 to be not either one, or 1 out of 6. So that was just a little extra. Okay, so go on to Blended Schools, enter your answer in on the quick check for 1 through 4, and you'll be good to go.